Okay, after we saw the definition of exponential functions, now in this video I want to talk about how to evaluate an exponential function and how to graph the function. So to evaluate an exponential function, it's better for us to review these two properties. These two properties from exponent and from the radical. So the first property is when we have a number b raised to the power of negative m, now this is equal to 1 over this number b raised to the positive number n. And when we have the b raised to the power of 1 over m, we can rewrite this into a radical. So it's going to be the nth root of b. Okay, now let's take a look at this example. Here we have this exponential function fx equals 3 to the x. Now, in this example, the base is 3. Okay, and we want to find out the function value f of 0, f of negative 1, f of 1/3, and f of 4. Now, please keep in mind, we said we wanted the b to be a positive numbers, but the input x, it can be any number. It could be any real number. Okay. So that's why we can use 0 as x, we can use a negative 1 as x, we can use a 1/3 as x, use 4 as x. Okay, so let's start with this. So to find what is f of 0, this means we're gonna substitute 0 for x. Now we evaluate what is 3 to 0. So 3 to the 0 equals 1. Okay, so the answer is 1. Next, to find what is f of negative 1. So this is equal to 3 to the power of negative 1. Now here, if we use this property, this will be 1 over 3 to the power of 1. So it's 1/3. And to find what does f of 1/3 equal? So this is equal to 3 to the power of 1/3. Now this time we're using this property, so it will be the cube root of 3. And the next, f of 4, so this is equal to 3 to the power of 4, which is 3 multiplied by itself for 4 times. So that's gonna be 81. Okay, it's gonna be 81. Okay, now let me show you how do we graph an exponential function. Say I want to graph the function fx equals 2 to the x. So the first thing we're going to do is to find a couple of ordered pairs, because only if we have those ordered pairs we can have points, right? And then when we plug those points on the xy coordinate, then by connecting those points we will generate the graph of this function. So the first step is I'm gonna set up this table and to find the points. So first I'm gonna choose some random values for x, and then using this equation to compute the corresponding y values. So when x equals negative 2, the y is 2 to the negative 2. So this is equal to 1/4. And when x equals negative 1, the y value is 2 to the negative 1. That is 1 over 2. And when x equals 0, the y is 2 to the 0. So that's 1. When x equals 1, the y is 2 to the 1, which is 2. When x equals 2, the y is 2 to the 2, that's 4. And when x equals 3, the y is 2 to the 3, 8. Okay, so now this is 1, 2, 3, 0. Okay, I suppose this is 8, so that is 4. Now this is 2. Now half is this 1. Now this is 1/2, and this is 1/4. Okay. Now the first point is negative 2 1/4. So when x equals negative 2 and y equals 1/4, so that point is here. And the next point is negative 1 1/2. So the point is here. And 0 1, so that point is here. And 1 2 is here. And 2 4 is here. And 3 8, so 3 8 is here. Now by connecting these points, we will be able to sketch the graph of this function. So now later on, I will use the decimals to graph some more exponential function, so therefore you will be able to compare their graphs. But right now, let me talk about this function. So one of the properties the function has is the graph of the function will pass the point 0 1. This is because for any of exponential functions like this, when x equals 0, the function value is always b to the 0 is 1. So for any exponential function like this, b to the x, the graph of the function always passes the point 0 1. Okay, and the second thing is here the function is going up. So we call this as an increasing function, which means the y value is getting big as the x value is increases, right? So as you can see, when the x values are increasing, the y values are also increasing. But not every exponential function is an increasing function. Now later on, we're gonna see some exponential functions and they are decreasing.